Hey there, algebra students. Mr. Lawrence here, and we're going to do a quick review video to help you get ready for the test. I'm going to try to do it as quick as I can. I'm not going to talk about every single type of problem that we're supposed to do. Some of the stuff you should have already mastered by now. If you got any questions, send me an email. Ask me in class tomorrow. Remember, the test is Thursday. All right, I'm going to graph this equation. It's in standard form. Remember, in standard form, I love to find an intercept. I look at C, and I see that 3 is going to divide into 6 evenly. So I'm going to solve this equation. Oops, I want to put 0 in for y. I'm going to find the x-intercept by plugging 0 in for y. And then I'll have my point, so I got a 0 there. And then that's going to equal 6. So this is 3x equals 6, and I'll divide by 3. And x is going to equal 2. So my my x-intercept is going to be the point 0, 2. Now, I could go find another point, but I'd rather find the slope. I remember the shortcut for slope is negative of a over b. And in this case, a is 3, so I want negative 3. B is negative 5. And those two negatives will cancel, getting me a 3, 5. And so I'll rise 1, 2, 3, and I'll run 1, 2, 3, 4, 5. Now, if I wanted to, I could use this slope, negative 3 over negative 5, to get the other point. I could go down 1, 2, 3, and back 1, 2, 3, 4, 5. And there you go. All right, so get my line here, something like that. And I really need to take up that graph, extend them, and put an arrowhead on there. I'm not sure why the default isn't a line, but I'm not sure how to change it. Maybe there is a way. All right, there we go. We just graphed in standard form. Whoa. Now, this one here is in slope-intercept form, except you'll notice it's an inequality, which means there might be a broken line involved. In fact, I know there's a broken line. How do I know? Because there's no equal sign. And because there's a less than, if there were a greater than, there would be shading involved. Since it's in slope-intercept form, I'm going to identify the y-intercept, which is going to be 0, 5. Go on the y-axis. All right. And then my slope is negative 3 over 1. So I'm going to go down 1, 2, 3, and over 1, and down 1, 2, 3, and over 1. All right. I need a broken line. Why do I need a broken line? Morgan knows, because it's not equal to, right? It's not equal to. So I'm going to do that, get my broken line. Now, because it's an inequality, a less than or greater than, then I know that I'm going to have to shade. Where do I shade? Well, I use a test point. I love to use the origin as my test point. It makes my math easy. I can't use the origin if the line goes through it. In this case, it doesn't, so I'm going to put 0 in for y. I'm going to put 0 in for x. And I'm going to get the statement that 0 is less than 5, which it is, and so therefore I will shade the origin side, or the test point side, of my dashed or broken line. Just like that. Okay, now the shading doesn't have to be perfect, as long as I know you're telling me all the solutions lie on the origin side of the line. Yeah. Any point I pick in there, I put in the inequality, I will get a true statement. All right, going real quick here, this should be review. Okay, here I have a system of inequalities. Uh-oh, hold on a second, there we go. So I'm going to have to graph both, and I'm going to have to do shading on both. And my solution set will be the region that gets overlapped, gets shaded twice. So the first one, the black one, is in standard form. I'll go looking for an intercept. I think, again, I'm going to look for the x-intercept, so I'll make y 0. And so I'll have 2x minus 3 times 0 is greater than 4. Oh, I want to remember when I actually find the point, I want to pretend it says equals to. When I do the graphing, I'll go ahead and use the greater than. So 2x is going to equal 4, and so then x is going to equal 2. So my x-intercept in this problem is 2, 0. I think it's the same as in the last problem, but that's just a coincidence. Pardon me. I just got done playing a tiring game of Spud at Boys Club. A lot of fun. Anyway, so now I need my slope, and I know the slope is found by doing the negative of a over b, which will be at positive 2/3. So I'm going to rise 1, 2, run 1, 2, 3, rise 2, run 1, 2, 3. Does it say equal to? No, it does not. Therefore, it's a broken or a dashed line because it does not say equal to. All right, properties, arrowhead. Now I got a shade. Now I'm not going to bring out the highlighter just yet on this one. I'll try to do it as if I was doing it in pencil. I can use the origin for my test point, and so I'm going to plug 0 in for x and 0 in for y, and that's going to get me 0 is greater than 4. 0 is not greater than 4, so I'm going to shade the side of the line that is opposite the test point. Okay, so I'm shading over there. Now I'm going to graph the one that's in slope-intercept form. So I see a y-intercept of 3. It should all be reviewed. That's why I'm going so quick. Slope is -1 over 5. I'm going to go down 1 and write 1, 2, 3, 4, 5. And down 1, 1, 2, 3, 4, 5. Now this one does have an equals. It's less than or equal to. Since there's an equals, it'll be a solid line. And so I will graph it like this. I know that's a broken line. I'm going to fix it in a moment. Okay. So let me make it solid. Make it a little bit thinner there. Make it solid. There, that looks pretty good. And I can use the origin for this test point, just using a different equation. So I'm going to test there. I'm going to put 0 in for y and 0 in for x. And I'm going to get the statement that 0 is less than or equal to 3, which is true. So I'm going to shade down here. What part of the graph got shaded twice? Well, it's this region right here. This part got shaded twice. I know normally I do the blue and yellow and they make green, and I really like the way it looks, but some of you were having trouble doing that on your homework, and so I wanted to show you where I had the black and the green lines intersecting. That's the part of the region, the part of the graph that provides all the solutions. So if I pick any point in the shaded region on forever, and I plug the coordinates into both equations, they'll both end up being true. In this region here, only the green line will be true, only where the green is shaded. On this part here, only the black one will be true. Here, neither will be true. Here, they're both true. All right, let me move that out of there so that doesn't confuse anybody. That's just a stray mark on accident. All right, so moving right along. Now we've got to graph some absolute value inequalities. Now some of you are having a hard time with this. I'm going to do number 5 first. Remember, the first thing is find the vertex. Okay, we find the x-coordinate of the vertex by changing the sign here. It says +6. We're going to use -6. We're going to use the y-coordinate of 1. We don't change the sign there, so I go to -6, +1. Make sure you're labeling x and y. No reason to get this wrong. There you go. Now my slope. My slope is the number in front of the absolute value. Well, I don't see a number, so I can assume there's a 1. So I'm going to use two slopes. I'm going to use the slope of 1 over 1 and the slope of 1 over -1. So I'm going to rise 1, run 1, and then I'm going to rise 1 and go back 1, rise 1 and go back 1. All right. And so my graph will be a V shape. Absolute value will always, always, always be a V shape. Okay. So this one here. The vertex. What number is being added or subtracted to the x? 0. It doesn't say plus or minus anything. That means there's a 0 in there. The x-coordinate of my vertex is 0. My y-coordinate is -4. So let's see, I got to put the origin in, I got to put x and y, and I have to go to 0, -4 right there. Now my slope. My first slope is going to be -2/3. The number in front of the absolute value. Then I'm going to use the slope of -2 over -3. So I'm going to go down 2 from the vertex and write 1, 2, 3. Down 2 and write 1, 2, 3. And then the other one is down 2, back 1, 2, 3. And down 2, back 1, 2, 3. And there you go. It's an inverted V. It's an upside down V. Why? Because the slope was negative. This should be a real easy test for you. If you prepare Like some of you have been working really hard. Rebecca's been working hard. I know that Allison Pasquale has been working real hard. This should not be a difficult test. All right. Rocky Romano's been working very hard. There's some people that have been working their butts off. So I'm proud of you. Keep it up. All right. We have to find slopes and midpoint. Remember, to find the slope, you're going to use the formula that m equals y sub 2 minus y sub 1. Excuse me. Sorry about that. I didn't have time to warn you about that sneeze. Over x sub 2 minus x sub 1. So the only rule here is I have to be consistent. My y's are going to rise to the top. And if I start with 12, because that's a y coordinate, I'll do 12 minus 8. Then I have to start with 6, and I'm always going to subtract 6 minus negative 5. And minus a negative is the same as adding a positive. And so 12 minus 8 is 4. 6 plus 5 is 11. My slope is 4/11ths. Now to do the midpoint is even easier. The midpoint is just averaging the x's. So you average, you add them together, divide by 2, and then you add the y's together and divide by 2. So to get the midpoint, you're going to add together 6 plus negative 5 and divide by 2, and then you're going to add together 12 plus 8 and divide by 2. And so in this case, I'm going to get 1/2. I'm going to get 10. My midpoint of the segment that would have endpoints here and here is going to be 1/2, 10. Okay. If you want, you can pause the video at any point and try these. You don't have to watch me do them. All right, I'm going to go a little bit faster now. My slope on this one is going to be 2 minus negative 5, so that's going to be a 3. 2 minus negative 5, because it would really be negative 2 minus negative 5. So negative 2 minus negative 5 is 3, because negative 2 minus negative 5 would change both of those. Okay. So we're going to put that over negative 3 minus negative 1. So that'll be negative 2. Negative 3 minus negative 1. Those two will change. You're going to get negative 2. So your slope is negative 2. All right. To get the midpoint, you just have to average. Add them together and divide by 2. So the midpoint is negative 4 cut in half, negative 2. Negative 7 cut in half, negative 3.5. And there's your midpoint. Piece of cake. All right, C. Get the slope. 6 minus 5. Oh, can't do 6 minus 5 because 6 is an x-coordinate. 5 is a y-coordinate. I can do negative 2 minus 5, which would be negative 7. 6 minus 6 is 0. This has no slope, or you may tell me that it's undefined. Right? It's no slope because you're not allowed to divide by 0. See the 0 down there? 7 divided by 0, negative 7 divided by 0. You can't do it. No slope, or you could tell me it's undefined. Either one. Not unidentified, undefined. All right, the midpoint, averaging the x-coordinates is easy, right? What point is in the middle of 6 and 6? 6. If I add negative 2 and 5, I get negative 3. No, I get positive 3. Negative 2 plus 5 is 3 divided by 2. So I could say it's 6 and 1.5. Or you could use the decimal version of 1.5 like that. Okay, last one here. So I'm going to do my slope, and I'm going to subtract negative 3 minus negative 3. Well, that's going to be 0 in the numerator. Denominator is going to be 8 minus 10, negative 2. 0 divided by negative 2, 0. My slope is 0. This is a horizontal line. All right, the midpoint. Well, I average 8 and 10, and I'm going to get 9. Negative 3 is going to be negative 3. There you go. Okay, now the only other thing that's not in this video is the story problems, but we saw it in the video the other night. We worked on it in class a little bit. So I'll expect you, I'll give you a situation, you have you write the equation, have you graph it, and solve it using your graph. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.